Hi everyone, it's Jimmy here at Jimmy Math Tutoring. Let's work a sample trig problem, trigonometry. Some people, have a great fear of trigonometry, but it's really not that bad, It just takes some practice, and I'm here to help you, So I want to just, do a little sample problem, give you a little bit of confidence that I know trig, and I can help you with trig in our math tutoring session. So this one is an identity, and they want us to prove that the equation is an identity. That's a common type of problem in trig, And so this one is, let me write it here. I found this out of a book actually. I haven't even worked it yet, so let's see how hard it's going to be. Tan theta minus sine theta divided by sine secant, and they're saying that is equal to tan theta over 2 sine theta. Okay, well, it's not something that you would just, know. You wouldn't just know that, but you're going to have to, the way I see it, you just, work with what you're given, and you can do, multiply by things, divide by things. But for me, I think what I'm going to do is I'm going to convert everything on the left hand side to sine and cosine. So I get sine over cosine minus sine, and then this is sine over cosine. That's actually just tangent. Actually, that's just tangent. I'm just going to leave that as that. Divide through, and you get a 1 right here. 1 minus sine over tangent, which is, that's just 1. So that's equal to 1 minus sine over sine over cosine. Well, that's equal to 1 minus cosine. So it's not. It's really a complicated way of just saying 1 minus cosine theta. So that's what that is. Now, can we get the other side? Can we work this side to be equal to that thing? That's the question. It's kind of like a game, They're saying that this is an identity. They're saying that this is an identity, and we need to prove that it is an identity, that it is true. Well, thing is, that's where it can actually kind of get a little tricky, if these, what we probably, I'm thinking maybe, I'm not sure yet, not sure, where to go with that. Unless we could just work with the right side and see where that took us. You could say that's sine theta over 2 sine theta over cosine theta over 2, and it. So really, let's move the cosine theta over 2 to the numerator. So let's multiply it right here, cosine theta over 2, and so then we're just left with sine theta over 2. See? So it boils down to, are these two things, equal? That's the real question. We're working with both sides, and are those two things equal is the question. And it's still not really completely obvious at all. It's really not at all obvious. So that means that you have to keep going, and the only thing that you can really do is convert. You see, you have to convert the cosine theta and sine theta into double angle formulas. It does require, I guess, a little bit of experience. I haven't worked this problem, but I do know that I want to make this into cosine of theta over 2 plus theta over 2. I want to do that type of thing. Split the theta into two parts, and then use this formula. You see, and that'll be a cosine squared minus a sine squared. See, so that's where we're headed anyway. So let's just work with that left side. And I don't know. Again, I don't know that I've got the problem solved. But I'm just thinking that if it's true, it has to be something that we can work out. So, so 1 minus cosine of theta times cosine theta over 2. Well, the cosine theta is 1 minus cosine squared theta over 2 minus sine squared theta over 2. Now, which one do I want? Well, let's just leave it like this for now. Cosine theta over 2. So what do we want? Do we want to put the sine in terms of the cosine or the other way? That's really... Well, I want to get rid of the 1. So, whatever helps me get rid of the 1, we already know that, sine squared plus cosine squared is 1. So we can, automatically convert between sine squared and cosine squared. That's the basic idea, So I think what I want to do is I want to convert the cosine squared to 1 minus sine squared, you see. So that I can cancel the 1s up here, you see. So, I want to do this. I want to put this thing in right here. That's where I'm headed with this thing, see. So we get 1 minus sine squared theta over 2 minus sine squared. Let's see what's going on here. Oh, yeah. So we get the cosine theta over 2 on the outside. So really, what we have is 2 sine squared theta over 2 times cosine theta over 2. If we get it to be that, and that's the question. That is the question. We get this thing right here, but we want it to be equal to this thing right here. That's the question. Are those two things equal? Is that thing, are those two quantities equal? And that's what we have to see. But remember the identity. Sine of 2 theta is equal to 2 sine theta cosine theta. Remember that. If you remember that formula, that's a key thing to remember, because that will help us, to resolve the issues. And it appears to me that if we take theta to be theta over 2, so if we say, so therefore sine theta is equal to 2 sine theta over 2 cosine theta over 2. This is the same thing, just theta instead of 2 theta, and then, see, what we do is we can go ahead and plug this thing right here in over here, right there. See, and see, will it equal to each other then? And I think the answer is yes. But let's do it. So plug this thing in for sine theta, and we get 2 sine theta over 2 cosine theta over 2, and then we get another times sine theta over 2. So let's collect. This is all one big long term. So we get a sine squared theta over 2. So we get 2 sine squared theta over 2 times cosine theta over 2. And therefore, that's the final result there, And it looks to me like, we get this and this. You see, same thing, same exact thing on the left and the right side. So, we've basically, done what they wanted. We've proven the identity holds. It was definitely messy, but I say work with both sides. Work with it however you can to make it simpler. Work with both sides. Do things to get it to work out. And that one did, but sometimes you might get stuck. There's no guarantee. Some of these things can be tricky. Especially if you hadn't really worked a lot of them before. But generally speaking, you just convert things to sines and cosines, and but you can't really easily work with the half angle formula. You have to know your double angle formulas, but it wasn't really that bad. It was a straight trig problem. So in a trigonometry, and is a problem like this important for later on, like in calculus or something? Well, yes. Yes, it really is. Because you do work with identities to some extent in calculus, but not necessarily this heavily. You don't usually see strange expressions like that, and you have to be required to get it into that form to be able to do something useful with it. But so this is really just an exercise in working with sine, cosine, and stuff like that. It's more just a pure exercise than something that is going to be critically important in calculus. But it is important to know the trig stuff. But this one goes a little bit beyond what you might do with trig stuff in calculus. You see, so that's I wouldn't worry about it too much. Even if it bothers you, this trig identity, even if it bothers you, says, man, I can't get I don't think I can go any further in mathematics because this stuff is just crazy. Well, calculus is not just all about trig identities heavily. It does get into trig is really used in calculus, but still, it's a nice little problem. It really gives you a workout, with some basic trig identities. So I hope that helps you. Thanks a lot. Jimmy, signing off.